Hey guys, now one part exercise 6F talks about how to find the unknown angles such as this one here. So how do we find theta? Well, before we do that, I'm going to actually go through some other examples, and these are examples that we're going to go through. But before we do that, we want to try and find out ways to actually eliminate everything around within the equation to get theta by itself. Before we can do that, we need to understand opposites. So you probably can see that when we're doing an equation like this, to remove and get x by itself, we would divide 2 on both sides. If we were to do this one here, we would multiply 5 on both sides to get rid of this. We needed to, now for this one here, when we got x squared or x to the power of 2, to eliminate the squared or the power, we would square root on both sides. Square root on both sides. But then when it comes to question that we need to do, we need to come up with a way of eliminating this. If we eliminate that, we get theta by itself. But how do we do that? So that's the question. To do that, we do the opposite of tan, which is inverse tan. If we do inverse tan on both sides, we will be able to get this question. So if I was to rewrite this question, tan inverse is equal to 1. Sorry, tan theta is equal to 1. And you probably know why I put the 1 a little bit further out. It's because when I want to inverse tan on both sides, I'll do tan inverse on both sides, and that will eliminate the tan, and we're left with theta equaling to, I think it's 45. If I check that on the calculator, inverse tan, 45, inverse tan of 1, inverse tan of 1 is 45. So that's pretty much it. Now, one thing that I probably wanted to explain to you guys as well, I want to actually import this calculator here, and I'll make it a bit smaller and just show you how to inverse tan. So what you would do is, it's going to make this orange. You would press shift, and then once you press shift, see how we have a sign here, no, not sign, tan. Okay, you notice that if you look at, there's a tan inverse there, but to press tan inverse, you need to make sure you press shift first and then tan, and that will give you your tan inverse. Okay, let's move on to the question. Now we want to try and find out theta on its own. Now to do that, the first step for that A, which is tan theta, is equal to 2.4. First step that we do is we write that we need to do tan inverse on both sides. Let's rewrite the question. So we have tan theta is equal to 2.4. Now we're going to try and inverse tan on both sides. So I'm going to write tan inverse here and tan inverse here. Now if we do that, you notice that this cancels. We're left with theta is equal to tan inverse 2.4. If we were to do that on the calculator, we would get shift tan inverse 2.4, it will equal to 67.38, and if we had to do that to the nearest degree, it'll be 67 degrees. Now we'll try and do, I'm going to get you guys to do this in class, or when you're doing it at home, I'll pause it for you guys, and yeah, so I'll give you a bit of time to actually do that yourself, so put it on pause. Alright, so with this one, obviously, we need to inverse sine on both sides. So let's do that. So I'll write the question again. So we have sine inverse is equal to 22 over 35. And you probably know why I've shifted a little bit further away from the equal sign so that I can actually fit inverse sine inverse. So we do sine inverse on both sides. I'm going to put the brackets here because we need to do it when we put into the calculator. And so this and this eliminate, allowing the theta to be by itself. So I'm going to write theta again. Theta is equal to sine inverse 22 over 35. And the answer to that is, let's do it on the calculator, 22 divided by 35, closed, and that is equal to 38. So theta is equal to 38.94. Now, if we had to do that to the nearest degree, it's closer to 39 degrees, so the answer will be 39 degrees. Okay, now let's move on to the next question. So we've got the worked example, the second example in exercise 6F, and you can probably see that the question is entailing that we try and find, within this triangle, we're trying to find theta. So to do that, before we do anything, because we need to actually apply a formula here, I'm going to just list all the variables that are in this problem here. And then we can try and come up with a step to actually answering this. So what we'll do is we'll put a list of the variables. I'm going to write list of variables. And they are theta, we've got theta here, and that's what we're supposed to find. And we have 7 and 10, so 7 and 12. 7 centimeters and 12 centimeters. Now we need to identify what I'm going to start with the 12 centimeters. We should know that because it's the opposite of the 90 degrees, 12 centimeters is the hypotenuse, and obviously the opposite of theta is not what we're after, so this is our opposite, and this is our hypotenuse, so therefore our 7 would be the adjacent. So I'm going to put adjacent here. Oops. 7 centimeters equal to our adjacent. And with these pieces of information, are we able to determine? So we have our adjacent, we have our hypotenuse, and you can see adjacent, hypotenuse, and I know that we need to apply this formula here. So let's go ahead and do that. So cos theta is equal to adjacent over hypotenuse, and let's substitute. I'm going to just copy this again and paste it, and I'll put it here like that, and in red I'll put the adjacent, which is 7, and a hypotenuse, which is 12. So therefore cos theta is equal to 7 over 12. Now, our aim is to get rid of the cos and just get theta by itself. So the step that we're going to take here is to inverse cos on both sides. So we'll do that. So we have cos theta is equal to, I'm going to put the fraction a bit further to the right, and now we're going to inverse cos on both sides. So cos inverse, put the brackets here. Just going to clean this area up here a bit. Now I'm just going to shift all of this onto this side here. So now we know that before we do that, you can see that our cos and cos inverse cancel. So we're left with cos theta is equal to theta is equal to cos inverse 7/12. And if you put that into the calculator, the nearest degree, that is equal to 54 degrees. Okay, that's about it, guys. I'm going to just end it here. Don't want to make the video too long. Thanks for watching.